Hello, this is John from caveofprogramming.com. In this tutorial we're going to look at exceptions in C++. We're going to start looking at them. So exceptions are an error handling mechanism. Let's imagine that we've got a function up here, but it could also be a method and it could even be a constructor. I'll call this function might go wrong. So this is a function where something bad could happen, something like an actual serious error. So like there's a fuzzy line between, on the one hand there's the idea that exceptions should only be used in error conditions that are really serious, that shouldn't happen when your program runs. But on the other side, there are a lot of people using exceptions to detect error conditions that absolutely are quite likely to occur. For example, files not being found in your program. So I tend to err on the side of only using them for things that your program can't recover from. And I would suggest that's probably the best idea on the whole, where possible. So we imagine that this function runs, and it's possible that it might encounter a serious error when it runs, which the program can't recover from. For example, we might not be able to allocate enough memory in this function to actually serve the needs of the program. So what we can do in here is let's have a Boolean condition, and I'm going to call this let's call it error and set it equal to true. So let's pretend that this error here has been set to true because some unfortunate problem was detected in the program. Something went badly wrong. We figured out that something's not working. We're going to say if error, so if the error occurs, throw. And let's throw here, well, let's try an error code, a simple error code like an int. So let's say 8. Now we can run that program, we can run this function quite normally, we can call it quite normally. If this error does occur when we run the program, then we are going to get some kind of error message. So we think of this error code in fact, as being thrown out of this function. Then the main function here isn't doing anything to detect that exception that's been thrown, that error. So the exception's getting thrown right out of main, and we're getting an error message here. So it's worth trying this to start with your compiler, with your IDE. I'm using Eclipse CDT and GNU here, because with some compilers you'll have to add some settings somewhere in your IDE to enable exception handling in C++. It used to not be switched on by default because a lot of people used to feel, rightly or wrongly, that exception handling would slow their program down. Well, rightly, but whether that's really something worth considering, a very minimal slowdown, is another question. I think these days most compilers will handle exceptions by default, but you might need to consult documentation or do a Google for your IDE and compiler and figure out how to enable exceptions. So if this does work, what we can now try is we can handle the exception. So this is an error message, but it's not that much use. What we can do is in our main function, we can catch that exception, in other words, detect the error. So I'm going to put a try in here. So this is a keyword in C++, try. And after that, I'm going to have brackets that surround the thing that might go wrong. And below this, I'm going to have a catch keyword immediately below. That has round brackets after it, a bit like the main here. And in these round brackets, we're going to have kind of an argument list. It's actually an exception that can be caught. In this case, we're throwing 8, which is an integer. So I'm going to type here int, and I'll just call this E for exception. This is one of the few places where I would happily use a single letter for to describe what's basically a variable, but usually I wouldn't do that. But your catch blocks are going to normally be pretty short, and it's pretty clear what E is. So now we can output E here. Let's say error code. and let's output E. So if we run this now, we find that we've got error code 8, and the program has in fact continued running. Let's put in here still running. So we've caught that exception, we've handled the exception, we say. We've caught it, and our program can carry on. And of course we need to take some kind of appropriate action here, which might be quitting the program. We need to do something because we've got a serious error here. You can throw pretty much anything, including objects, as an exception, and we're going to get onto that probably in the next tutorial. But let's take a look at something else here. So instead of throwing 8, let's throw this, some kind of error string. Let's say something went wrong. If we run this now, we find that the error isn't caught, it's being thrown out of main. And we see it says, well, at least for my compiler, and hopefully your compiler will also give you an error message if you don't catch an exception. It says terminating with uncaught exception of type char const pointer. So if we have a string in here, the type of this is, if we throw a string in our function, the type of it is going to be char const pointer. We're talking about a primitive string here. So we could change this here, but what we can also do is have multiple catch blocks. Let's put another catch in here, and let's say here we want to catch char const pointer. We'll call it E again, because the scope of this E is limited to these brackets, so we can use another E here. And let's put this here, let's say error message, and see if we can catch this error message. And in fact we can. So we could have multiple errors in this function. We could have, let's say, error 1. This is error 1. Let's have bool error 2 equals true. And let's maybe let's put this down here. So if error 2, let's try now throwing a string, an actual string. So to throw a string, we can say string. We use this syntax, so we use the class name. If we want to throw an object here, we use the class name followed by round brackets, and we can initialize our string with some text. Let's say something else went wrong. Now if we run this now, we're going to throw this first exception because error 1 is true. If we throw this exception, as soon as the exception is thrown, the function stops executing, so this is not going to occur. Let's run this and prove that. So it says still running from main, and it says something went wrong, which is coming from this exception. So we never even get to here, because as soon as you do a throw, you go straight out of your function. And in fact, this function could even be called from within another function. It could be nested, and we could still catch it anywhere we like, higher up the stack of function calls. Let's set error 1 to false, so we're not going to throw that. We're going to throw error 2, which is a string now. Let's try this. So now we've got an uncaught exception of type string. So we can put another catch block in, and it's common to have multiple catch blocks like this to catch different kinds of error. We'll try string E like this, and we're going to put a cout in here. String error message, let's say, and let's output E like this. So I'm getting a warning in my IDE, and you probably will too, because what it's saying catch by reference is recommended for strings. So when we throw objects, this is an object. It's a slightly weird way of constructing an object, because there's no new in there, but it does look a bit like, well, not really actually. It doesn't really even look like a variable declaration, but this is creating an object from the string class. But what we need to do is catch that object with a reference. So normally you don't want to return a reference from a function, because it's then referring to something that's gone out of scope, and we saw that in my free beginners C++ course. But with exceptions, it's different. The C++ compiler will instantiate this object and it will clean it up as well. That's part of the exception specification. So you don't need to use new in there. That wouldn't work, or not as you intend. You just use this kind of syntax and this string will be cleaned up later. Let's try running this now and see if it works. So now we've got something else went wrong. We're correctly catching our string exception. One last thing I want to show you for this tutorial is that even if I create some other function, let's call it uses might go wrong. And let's call might go wrong like that. And in here, let's call uses might go wrong. So now we've got a nested function call. I want to call that uses might go wrong. We've got a nested function call. We're calling uses might go wrong, which calls might go wrong, which in turn is detecting the imagine an error condition and throwing an exception. So we could handle the exception here, but we're not doing. So the exception is going to get thrown all the way out of this function. And then finally, we are handling it in main. And if we didn't handle it there, it will get thrown all the way out of main. So exceptions get thrown all the way out of what we call the call stack of all the different functions that call each other. So let's run this now. And I've got some error there. Let's see. Might go wrong use of... Yeah, in fact, I didn't put a prototype in here, so I'm going to have to call them in the right order, again, as we've seen in the beginner's course. Okay, so that's better. Let's run this now. Hopefully that should work. So I'll run this, and now we see we're getting string error message. So we're throwing the exception out of might go wrong, out of uses might go wrong, and finally we're catching it here in main. So I'm going to give you like a exercise at the end of most of the tutorials, and the exercise is usually going to be to repeat what I've just done. So I'll suggest that you first just try throwing and catching a basic exception in your program, and then try throwing and catching at least these different types, and you can experiment with others if you like. We're going to actually carry on looking at this in the next tutorial, but try throwing and catching an int, also try a primitive string, some text in double quotes, and try a non-primitive string as well. Of course, to use the non-primitive string, you've got to use IStream and using namespace standard in there. So have a go at that and check that you can throw and catch all these exceptions. So remember, the idea is that as soon as you throw something in a function, the function stops executing, and you can then catch that exception anywhere up the call stack. So like most C++ concepts, or in programming in general, this looks a bit difficult to understand when you first see it, but once you actually try it, once you've typed it out, it's actually really pretty simple. So have a go at that and try ultimately to get a program like this working. I'd recommend always that you try it just from memory first, but probably you're going to have to refer back to this tutorial and try to do as much as memory from possible until you finally get it working. Once you've got it running, then you won't have you won't feel really fluent with it, of course, until you actually use this in your own programs, which is another great thing to do. But it will be there somewhere in your mind once you've got code like this working, and that's a really, really good start. Okay, so that's it for this time, and until next time, happy coding.